Okay, here's part 3. A few more problems about inequalities and solving formula problems with area. Number 33. Find the area of the window. If necessary, use pi, which is approximately 3.14, and round your result to the nearest tenth. Okay, so find the area of the window. We have to find the area of this top part, the circular part, and the rectangular part. So the area of a circle is right here. I just wrote it in. It's area of a circle is pi r squared. So you have to figure out, well, you know what pi is. We've already been given pi. It's right here. We use that. And the only other thing we need to know is the radius. Well, you look at it and you say, well, hey, there's no radius on there. Well, in a way, you're right. This distance here, though, is 6 feet, right? And that's the diameter. That's the same as that. This here is the diameter, and the diameter equals 2 radiuses, because the diameter goes all the way across the circle. The radius is from the center to the end, to the edge of the circle. So if you have the diameter, this would also equal, if we divide by 2, we're going to get r equals the diameter divided by 2. So our radius is 6 feet over 2, which is 3. So we can figure that. We've got pi times 3 squared. And since we're only dealing with half of a circle, we're gonna have to divide this by 2. Okay, so pi equals, in our case here, 3.14. 3 squared is 9, so it's times 9, and the whole thing is divided by 2. And that will give us 14.13, or 14 1300ths. And we're not going to round it down to the nearest tenth yet. We'll wait till we get our answer. And this is 14.13 what? Well, square feet. Oh, we're in blue. Square feet, because we've multiplied feet times feet here. We multiplied the radius, which is feet, times itself. So feet squared. And in a way you could think of it as how many little squares will fill up that semicircle there, that half circle. Now we need to also find the area of the rectangular part. And that is 6 times 11, right? 6 feet times 11 feet. Nice and easy. So here we have 66 square feet. Okay, we'll add them together. 14.13 and 66. It's hard to tell what I wrote there, isn't it? Okay, and that gives us 80.13 square feet. But now we'll go back to rounding it to the nearest tenth. Since 3 is less than 5, we'll drop it, and so our total is 80.1 square feet. Okay, number 34. Find the area of the geometric figure. Okay, so here we have a rectangle and a triangle combined together. The area of the rectangle is this, length times width. Area of a triangle is 1/2 the height times the base. And on your exam you'll be given the formulas for these. So you don't need to memorize them, though you should have done them enough actually to have memorized them. Okay, so let's start with the triangle. We have to find the base of the triangle first. We already know the height the height is this. This equals h. Okay, and this is the base, B, of the triangle. However, it doesn't give us the base, but it does give us the dimensions of the rectangle. And this area here, from here to here, it's 2.5. From here to here, let me do a different color, blue. From here to here and here to here, 2.5 each. So 2 times 2.5, which we could write 2 over 1 times 2 times 2 is 4, plus 1 is 5. 5 halves equals 10 halves, which is 5, or you can just cross cancel, and we get 5. 5 over 1 or 5. So, meters. So, these two added together, or multiplied times 2, gives us 5 meters. And then we subtract that from 10 meters, and we get what this distance is, which is, 10 minus 5 equals 5. So the base of the triangle is 5 meters. Okay, so area of our triangle equals 1/2 the height, which is 2, times the base, which is 5, which equals 2 times 5 is 10, half of that is 5. Okay, 5, is it 5 meters? No, 5 meters squared, right? Remember from the last problem. Okay, then our area of our rectangle is this, whoops, there we go, which is 10 times 4 over here. It's 40 meters squared. Add them together, we get 45 meters squared. Number 35, solve and graph the following inequalities. Alright, this is the first of the, 3 I think, or 4. Write the answers in set builder notation and interval notation. Okay, so our first inequality is a negative 11n plus 2 is greater than a negative 12n minus 6. Alright, so let's rewrite it down here. I want black. Alright, negative 11n plus 2 is greater than negative 12n minus 6. Now we can treat these like they're equations, but don't change the inequality sign. Don't change the direction of this unless you multiply or divide by a negative number. Otherwise, you leave it in there the whole time, just like you would if you were working with an equation. You'd leave the equal sign in there, right? So, first thing we do, we can either deal with the numbers. We get the numbers on one side and the variables on the other. Numbers are called the constants. Okay, so I'm going to deal with the variables. It doesn't matter which one you deal with first. The numbers or the variables or the constants. So I'm going to add 12n to both sides. So we just do it just like we would with a equation, except that if we multiply or divide by a negative number, we have to change the direction of the inequality. Alright, so if I add 12n to both sides, then I get 1n, or n over here, is plus 2, is still greater than negative 6. Okay, so now I want to get all the constants on the right, so I'm going to add a negative 2. Okay, and that gives me n is greater than a negative 8. Okay, so now if I'm going to graph this, I think I'll put my negative 8 in first. Let's see, let's go to a different color. Okay. Okay, this will be my -8. So this would be -7, -6, -9. Whoops, that's not a 9. Pretend that's a 9. -10. Alright, let's go back to black. Alright, so n is greater than -8, so it's greater than doesn't include 8, so we use the parentheses, and then we make our arrow. It's greater than, so it goes in that direction. Okay, now let's just write the interval notation first, and then the set builder, because we just did this. We just did that thing. So our set builder, or interval notation, starts at a -8. And it doesn't include -8, so I use the parentheses and a comma, and it goes to positive infinity. So I use the parentheses again. Alright, so that's our interval notation. Then our set builder notation is quite easy. Set builder notation, we use a brace, and we're dealing with n's, right? So we'll put n, and then this line means such that, or n, how do we use n? And we use n, or n tells us that n is greater than -8. So set builder notation is very easy to do. You're just taking this thing and putting it in there. That's all you're doing. And then the variable, you just say, what the variable is. It's like saying, well, our variable is n, so here's what we do with n. So the proper way of saying it is set of n such that n is greater than -8. Number 36. Alright, the inequality here is a -2x is greater than 4. I'll rewrite it. -2x is greater than 4.
What's it like out?
Okay, I want to get the x. My wife wants to know what it's like out.
Oh.
It's very nice out.
Sorry.
Nice out today. It's in the 40s, sunny. Alright, so now I'm going to divide by -2, because I want to get the x alone. -2, -2. Okay, so those -2's cancel out, and so I have x, and x is now less than, and 4 divided by -2 is a -2. So x is less than -2. Notice that I turned and reversed the inequality sign because I divided by a negative number. Okay, that's all there is to this. That's the only difference in working with this and working with equations, besides the fact that we keep our inequality sign. We don't turn it into an equal sign. Okay, I'm going to just put my -2 right in the center. -2, so this should be -1, 0, 1. This would be -3. I'm not going to bother writing the rest in because I already blocked the space with something else. Well, maybe if I put a line around it. Yeah, still. Alright, so I'm just going to use this part of the graph. Okay, so x is less than a -2. So, parentheses, arrow. Okay, and then the interval notation that goes with that, you go from left to right in interval notation, so it starts at -infinity. You always use a parentheses with -infinity because you don't know, you can't, it's not a number. It's just kind of like a direction. Infinite. Okay, and then it goes up to, but not including -2. So a parenthesis on that. And set builder notation, we're dealing with x now, so it's this x such that, and we just stick this in there, right? X is less than -2. Not that hard, really. Just a little practice with this and you get comfortable with it. Number 37. x divided by 2 plus 5 is less or equal to 7. Okay, I'll rewrite that. Okay, we want to get the x term alone. In this case, it's x divided by 2. So we'll add a negative 5. So that becomes 0. We have x over 2 is less or equal to 2. Now, we want to get it. We know what x divided by 2 is. We want to know what x is. So we have to multiply both sides by 2. Multiply by the reciprocal of x over 2. Or reciprocal of 1/2, I mean, which is 2. So x divided by 2 times 2. We put it 2 over 1 is less or equal to 2 times 2. Okay, so these cancel out, and we have x is less or equal to 4. Okay, so graphing, I'll just put the 4 here first. 4, 5, 6, 7, 8, 3, 2. X is less or equal to 4. Okay, so it's less than 4 or equal to, so it gets one of these. I should change pen color. It's one of these, and the arrow, it's less than. So now I'll do the interval notation first. So it goes from left to right, so it's a negative infinity, starts at negative infinity, and goes up to and including negative 4. Oh, these are, no, it's positive 4. I'm sorry, positive 4. And then in set builder notation, it's this, x such that x is less or equal to 4. Okay. Okay, number 38. This is the last one. We have a negative 1 minus 5a plus 7 is greater or equal to a negative 6a minus 4. Okay. Just because there's more stuff in it doesn't mean we can't do it. Just treat it like it's an equation, but we keep the inequality sign. So I'll just rewrite it. Okay, so first, always look at both sides, and if there's something you can combine, you do. So we've got the negative 1 and the 7, so we combine those and we get 6. So we have a negative 5a plus 6 is greater or equal to negative 6a minus 4. Okay. So now let's add 6a to both sides. 6a, 6a. Careful to add like terms all the time. Okay, 6a combined with the negative 5a is just 1a or a. So plus 6 greater equal to a negative 4. These cancel. Okay, and so now let's add a negative 6. Add a negative 6. And this cancels out. 6 minus 6 is 0, so a is greater or equal to a negative 10. Okay, so now let's go up and put it on our graph. I'm going to put, I think I'll put negative 10 here. So 7, 6, negative 11, negative 12. Okay, it's greater or equal to a negative 10. Okay, we'll do the interval notation. Oops, doesn't use that one. It includes negative 10. It's greater than or equal to negative 10. So it includes negative 10. And then it goes to positive infinity, which is always a parentheses. And then in set builder notation, we just use this thing, right? Make that. We usually talk about A, so A such that A is greater or equal to a negative 10. And there we have it. Congratulations. Happy trails to you until we meet again. Happy trails to you. Keep smiling until then. And I think you know the rest. If you don't, you can look it up. I think it's Gene Autry or Roy Rogers.